Welcome to our today's lesson, and today we want to solve simultaneous equations using the matrix method. So our equation, the first equation is 3x plus y is equal to 7 and 5x plus 2y is equal to 12. So what do? The first thing we do is to extract the coefficient of the elements, the coefficient of the unknowns, these matrices. So for example, here we now have the coefficient of x here is 3, and the coefficient of y is 1, and the coefficient of 5x is 5, and the coefficient of 2y is y. Then x and y forms the column matrix here. So x and y forms the column matrix, and then we have 7, 12 there to form the solution matrix. So this is the coefficient matrix, and this is the unknown matrix, while this one is the solution matrix. Now, having done that, then we now find the inverse of the unknown matrix. So the inverse of the unknown matrix, the first thing we do is to find the determinant. And determinant is the product of elements in the leading diagonal. This is the leading diagonal, and this is the other diagonal. So a product of elements in the leading diagonal, that is 2 times 3. We subtract 5 by 1, and that one gives us 1 here. So that is now the determinant. So for us to get the inverse, therefore, to get the inverse is now 1 over determinant. Inverse is now 1 over determinant, and then we interchange the position of this element. What was here was 3, 2, so 2 comes here and 3 comes here, and that's what we have here. So here is 2 and here is 3, and then we negate the other elements in the other diagonal, so these are negated. Then we multiply by 1 over determinant, and since 1 over 1 is 1, so the inverse remains 2, negative 1, and negative 5, 3. So that is now the inverse of our matrix. So the next step, we now pre-multiply. So pre-multiply the inverse by the two matrices. So pre-multiply, so we are pre-multiplying, so we write the inverse matrix here and the matrix itself. Then we have x, y, and then we pre-multiply the solution matrix by also the inverse. So that is how we arrange that work. So we are going to multiply a matrix times its inverse should give us the identity matrix, which is 1, 0, 0, 1. So that is the identity matrix, which we now multiply by the unknown matrix, and the other side also we pre-multiply. So when we pre-multiply, it is now Roman, that is row, we multiply by this column, and that is now 2 by 7 plus negative 1 by 12, and that one gives us 14. That one gives us 14. Then we also multiply this row by this column, that is negative 5 times 7. Then we add to 3 times 12, and that one gives us 36. That one gives us 36. So we have 14 minus 12, and then you have negative 36, 35 plus 36, and that gives us 2, 1. Now, when we multiply identity by a matrix, then we get that matrix. So identity times the matrix is that matrix, and therefore we get xy here, and therefore xy is now equal to 2, 1. And if two matrices are equal, then elements in the same element position are equal. Therefore x is equal to 1, and x is equal to 2, and y is equal to 1. So in that case, we have our x to be equal to 2, and our y is equal to 1. So in that case, our x is 2 and our y is 1, because elements in the same element position are equal. Therefore x is equal to 2 and y is equal to 1. So that one is how we solve that matrix.